Alright guys, hope your week's been going well. I'm looking forward to seeing you tomorrow, Thursday. For today's lesson, we're talking about performing operations using exponents. So, I guess I should start with talking about exponents again for a minute. So, if I were to show you 3 squared, what does that mean? Well, remember that the 3 represents, we call that the base, and the 2 is called an exponent. And what that 2 tells us is that we take the base and times it by itself 3 times. In other words, 3 times 3. So that's what it means. So 3 squared is a shorter way of writing 3 times 3, right? Okay. So if I asked you to now do 3 squared times 3 to the third, what kind of answer, if we kept it in exponent form and not actually solved it, if we kept it in exponent form, can anybody guess what my answer will be on the right-hand side? Well, my base remains a 3, but what does my exponent become? Well, let me clear the board and put our problem right up at the top here, and let's work through it. And let's first expand it like we did with the 3 squared. So 3 squared expanded out is 3 times 3, right? And then we have this multiplication symbol, and now we need to do 3 times 3 times 3 to represent this guy, right? So this guy is right here, and this guy is right here. Okay? So now do you see it? Our answer in exponent form is going to be base 3 with how many exponent? What number on our exponent? 1, 2, 3, 4, 5. So there you go. So when you multiply two exponents that have the same base, you rewrite the base, and then what happens here is that you really add them together. So let's try another one. 5 to the fourth times 5 to the third equals 5 to the what? Well, if this guy says 5 times 5 times 5 times 5, and this guy says 5 times 5 times 5, then our final exponent should be 7, 5 to the 7th. Okay? So hopefully that's making sense. So if I would write out a rule for this for you, product rule for exponents, which is what I wrote at the beginning of this. It says to multiply constants or variables. And what's a constant? Who remembers? It's numbers, right? And variables are the letters. So to multiply constants or variables in exponent form that have the same base, And that's important. Same base, meaning that same number. Like in the other one, it was 3 squared times 3 to the third. So that 3 was very important. Or in the 5 version, 5 to the fourth times 5 to the third. The base is the exact same number or the exact same variable. So if that's true, then to solve in exponent form, all you do is add the exponents, but keep the base unchanged. So let me give it to you. It's kind of in a formula version. If I have x to the a times x to the b, that is written as x as my base, so the base comes over and it's a plus b is my final answer, which is what we saw in those other ones. The base 3 and base 5 that I just showed you. Okay, so to recap, remember, as you're doing this homework assignment, that there are 3 things that you need to keep in mind, and that is that the first rule is that we can use the product rule. We can use this rule, we can use this product rule only if the bases are the same. And the other thing to keep in mind is remember that we add the exponents So, in other words, we don't multiply those exponents, we just add them. And then also remember that we don't multiply the base. We just bring the base over in our answer. Okay. Bases, I should say. Okay. So let's do some more practice ones. So let me do an A. We're going to do x to the third times x to the sixth. So you should write these down on your paper. X to the seventh times x. And then Debbie, if you're showing this in class, pause it after I write out A, B, and then we're going to do C and D. Give the students a chance to solve it, and then resume to see if they did it right. And C is going to be 4 to the fifth times 3 to the fourth, and 2 squared times 2 to the fourth. Okay, remember those 3 rules about product rule when solving these. So go ahead and pause, and when everybody thinks they have their answer, check with the partner, and then resume. So for A, rule. The first rule is that you remember to bring the base over, that the bases are the same, so we ask ourselves, are the bases the same? And what is our base? For A, our base is x, right? X is our base. So that one rule applies. 2 says, the second thing to remember is to add the exponents, right? Do not multiply the exponents. So we add the 3 plus the 6 to equal 9. And we didn't multiply our bases. We just brought the base over. So the answer to A is x to the 9th. For B, let's go on to the next one. B, again, I'm going to ask the rules. Number 1, we can use the product rule only if the bases are the same. Is our base the same in B? Yes, it is. So for letter B, our base is just brought over. Now, here's where some of you may have missed. The next part is to add the exponents. But some of you might be saying, but Nina, the second variable doesn't have an exponent. Oh, yes, it does. Remember, when it's not there, what is it? Is it 0? Is it 1? What is it? Well, let's write B out so that you can see it. X times. So x to the 7th is x times x times x times x times x. 1, 2, 3, 4, 5 times x times x. And then that second one is times x. So what's our final answer going to be? How many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8. So our answer for B is x to the 8th. So if you don't see an exponent there, we can assume that it's actually a 1. Okay? So that's our answer to this guy. This guy, the answer, final answer is x to the 8th. Okay, let's move on to C. So again, we ask ourselves, we need to remember we can use the product rule only if the bases are the same. Are the bases the same on C? Well, the answer is no, the bases are not the same, so we're stuck. We can't do this one. In fact, the answer to C is just what's written there. There is no way to condense them. So that one was a little tricky. But that's actually our answer. So if the bases aren't the same, we are not going to condense them, squish them together. We're just going to leave them like that. Okay? Yes, I know we could solve this further, but that's not our point. This whole homework assignment is about keeping it in exponent form when there's exponents there. Okay. So let's look at D. And D says 2 squared times 4 squared. So again, do we have the same base? Yes. So for D, our base will be 2. And then step 2 says we're going to add the exponents. So we're going to add 2 plus 4, giving us 2 to the 6th. How'd you do? Hopefully pretty good. Alright, let's look at one that might be a little bit more tricky. Three x to the 4th times 4x to the 7th. So if we were to write this guy, how would we do it? Well, let's go back to the remembering that when a number next to a letter, what does that mean when there's no symbol? I just heard you all say it. It's times. Okay, so then let's write this out. let's spread it out. 3 times, and then x to the 4th is x times x times x times x, right? So there's that guy. And then let's do this guy over here a little bit. So again, when there is no symbol, even with parentheses, what does that mean? It means times, right? Times. And now we're going to do a 4 and times x times x times x times x times x times x. I'm running out of room. 1, 2, 3, 4, 5, 6 times x. Oof. That's long, right? And who remembers the rule of multiplication? Can I do 3 times 2, but I could also do 2 times 3? I'm going to get the same answer, right? Yes, hopefully you all said yes. So, why is that important to know? Because I can take my 3 and I can take my 4 and I can put them right next to each other, 3 times 4. And then I can line up all the x's next to each other, right? And then what's the rule when the bases are the same? We add the exponents. So 4 plus 7 is 11. But now we have this 3 and this 4, this 3 times 4. Well, we can multiply those guys together, right? 3 times 4, 3 times 4. And so these guys become 12x to the 11th as our final answer. So hopefully that made sense. I'm recording this late at night, midnight on Wednesday, so you may hear the sleepiness in my voice. Alright, so let's practice that one again. $7a times a to the 3rd times 4a to the 6th. Okay, so let's practice what we learned at the beginning of this lesson with the rule of the product rule for exponents. Okay, so let's just look at the a for a second. Ignore the 7 and the 4. And let's just look at the a. So we have a times a to the 3rd times a to the 6th. Well, the rule is that you bring down the base, right? And then you add up the exponents. Now don't forget, an a that's all by itself is really 1a, right? It's just an a, right? So we got to take that 1a plus 3 plus 6. So 1 plus 3 is 4, plus 6 is 10. That's a 10. That's a messy 10. Let me erase that. Try that again. 10. a to the 10th. And now we can look at 7 times 4 and multiply those together. And 7 times 4 is 28. And that's our final answer, 28 a to the 10th. Is that making sense? I hope so. Let's try another one. How about this one? 5 x to the 6th times 7y squared. No, 7y to the 4th, excuse me, times 2x to the 4th. Okay. What are our common variables? Or common coefficients, I should say. We've got these what are called numerical coefficients, this 5, this 7, and this 2. So we know those guys can be multiplied together. And remember my trick about grouping? So don't do 5 times 7 first. Do 5 times 2 first, right? Because 5 times 2 is 10, and then 10 times 7. See? So you can get to 70 quicker that way. So 5 times 2 is 10, times 7 is 70. Right? Okay. So now we got to go back to our product rule for exponents, and we look for bases that are the same, and you should have noticed that the variable coefficient, or we have an x and we have a y. We can't combine those, but we can combine the x's. So we can combine this guy and this guy, right? So we're going to write an x next to our 70, and we're going to add 6 and 4 to get x to the 10th. And then we don't have anything to add the y to, so y to the 4th comes over, or comes down. And that's our final answer. Can't combine y to the 4th with anybody. So 70, x to the 10th, y to the 4th. Okay, let's try another one. We're going to bring negative numbers in this time. 5x times negative 8x. Okay, so let's combine what we can. So we have the constant here of 5 and a negative 8. And what is a positive 5 times a negative 8? Negative 40. Hopefully you all said it. And x times x is x squared. So hopefully you got that too. Remember, when there's no exponent there, think of it as a 1 next to it. And that's our final answer. Negative 40 x squared. Let's try another one. Alright, my handwriting's getting sloppy. That's not good. Okay, this says negative 7x squared times negative 4 y to the 4th. So let's see if we can condense any of this. Well, we already know that we can condense the numbers. Negative 7 times negative 4 equals positive 28. And then remember the rule of bases. We have an x and a y. Can we combine them? Hopefully you all said no. So our final answer there is 28x squared y to the 4th. We can't do anything with these guys except stick them next to each other. Okay, got it? Alright, now it's your turn. Alright, I'm going to write these on the board. Debbie's going to pause it if she's listening to this in class, or if you're watching this outside of class, you're going to pause it, you're going to try them, and then you're going to resume, hit play after everybody's got it down. Negative 6a times negative 8a. That's number 1, or letter B, or letter A, and then letter B we're going to go 5x to the 3rd times negative 2y to the 5th. Okay, hit pause. See if you can do it. Check with the partner. Then let's hit play. Alright, so let's see how you did. Negative 6 times negative 8 equals positive 48. And a times a is a squared. How'd you do? Hopefully good. a squared. I don't know why I keep making a mess. Okay. Alright, let's look at B and let's see if you got that one. 5 times negative 2 is negative 10. Uh-oh, different bases. So we can just bring these guys over. X to the third, y to the fifth. How'd you do? Hopefully good. Okay, let's look at some more problems. Actually, I think that's good. I think I've given an example from your homework, and you should be good to go. So I was going to put some distributive property ones on here, but I decided not to, so we're going to keep it simple today. So you may be able to get through your homework during class time today, which will be nice, so you'll have less homework. But just make sure you get through all of it. Raise your hand if you need help. Help each other out. And again, I will see you on Thursday. Alright, class. Take care.